Swayam Prabha. Digital India. Educated India.
Let us see why do you want to do analysis. Now, if you see, these structures are built without much knowledge of what stress is, what strain is, or what causal relationship is. The pyramids date back to 100 BC or something like that. The Brihadishwara temple or the big temple in Tanjavur is around 1000 years old. The Leaning Tower of Pisa is also around 1000 years old. In contrast to this, what is the difference that you see in this structure? The difference is the sleekness of the structure compared to the massiveness of these structures. Now, this is where the current science helps us. Basically, the resources you have is limited and you want to use those resources effectively, meaning you do not want to waste resources. You do not want to build a structure to last for 10,000 years when the intended design life is just 50 years or 100 years. Similarly, you do not want a structure to fail in 20 years when you intended to last for thousands of years. Okay? So, that is the intent. You want to use resources economically. When you say you want to use resources economically, you should have an understanding of how the structure responds to a given scenario or when the structure will fail. Now, when I say failure, what do I mean by failure? Is concrete crushing a failure? Is steel yielding a failure? Is a garbage bag just deforming too much under the weight of the garbage load? Is it a failure? That is the question I am asking. In other words, is this the failure of the body or is this yielding which has occurred and buckling that has occurred the failure of the body? What is failure? We have to understand this before we proceed. Failure by definition is if the structure does not fulfill its intended use, then it is said to have been failed. I will give you some examples. In the buildings, you have a reinforced concrete beam which would have failed, which would have cracked due to the dead load. That is not a failure of the beam. The same reinforced concrete beam, if it were to be part of a water tank, the cracking of the beam is detrimental because water will seep in through the cracks, deteriorate the concrete, and it might also cause leakage of water stored in the tank. So, what is not a failure in one case can mean failure in a different scenario. Okay? So, the reinforced concrete beam which has cracked because of tension in the bottom is not considered as failed in a regular residential buildings. Okay. The same reinforced concrete beam in the same residential building, part of a water tank, is considered to have failed if it cracks because water might seep in through the cracks. Okay. Similarly, the yielding of a structure under earthquake scenarios is admissible provided the structure does not collapse due to this yielding of the steel members or yielding of its components. On the other hand, if the steel member were to yield under a normal live load situation, normal loading situation, then it is considered to have been failed. In both these examples, it is a load that causes cracking or the failure of the body. There are other instances wherein it need not crack, it need not yield, but still the structure would have been deemed as failed because it has not served its intended use. Examples of these are these mobile antenna towers, this weather antenna towers and so on, wherein it is essential to maintain the deformed shape or it is essential to maintain the shape of the structures accurately, because the mobile tower will not be able to receive signals if it deforms more under a wind load or under heavy rains and so on. Similarly, this weather antenna would ask to maintain its parabolic shape under extreme wind loads. If it does not, it is deemed to have been failed, because it is used to track the cyclones and things like that, and you do not track cyclones when there is quiescent conditions. Okay. So, basically failure means different things under different scenarios. There can be failure because the strength or the stresses exceed a limit, or it can be displacement cause failure when displacement exceeds a limit. Another example of displacement induced failure is, say you are walking on this floor, and if the floor sinks by a meter, do you feel comfortable walking on the floor? No, right. So, that is an example of a displacement criteria governing the design. Okay. So, in essence, there are two reasons why you want to do analysis. The first reason is to ascertain the safety of the structure under given conditions. Okay. When I say safety of the structure, it means I do not want the structure to fail. When I mean safety of the structure, I do not want the structure to fail. So, there are two criteria here. One is strength and the other one is displacement. That is, I want to find and ensure that the stresses in the body does not exceed a particular limit for the given loading conditions. Similarly, in displacement, I want to compute the displacement on the boundary of the body or in the interior of the body where it is not specified, and I want to ensure that the displacement is within limits. Okay. So, strength means I want to compute the stresses in the body and ensure that these stresses are within the limits. Similarly, displacement means